Hey everyone, hope you all are doing good. Thank you for joining us today at samosa.net. I am Partharu, event planner for Microsoft Reactor India, and I welcome you all to our session. Before we begin, let's take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you all engage. Yes, we do all encourage you to participate. Please drop all your questions in the chat section. I would now like to bring in Vivek and Nish, our hosts for the session. Hey Nish, hey Vivek.
Hey,
Hey,
hey
Parth.
everyone.
This is for the first time Parth didn't freeze.
Oh,
It's like there's no
He didn't
frozen path.
freeze. It's
Yep.
Parth. No frozen. Yes. Frozen ice cream. Cool. Anyways. Hey, Nish, we're back. And what's up? What's happening?
You tell us what's happening. There's a lot happening around, the announcements on the Bing that we were just chatting about just before this getting in. A lot of AI stuffs. Looks interesting. So yeah,
Yes, we are all
okay.
bingified.
I take
Thanks,
your
Parth.
leave. Yep.
thanks, but
Go have your samosa. Okay. He- cool. Yeah. Yeah. So we are all bingified.
hmm
Huh?
yeah, isn't it
Cool.
amazing that what things it can do?
Yes. And what are we doing today? Today, we are going to talk about DAPR for .NET developers. That's what we have planned. It's a packed agenda today. I know we have a bunch of demos. I'm going to bring the slide in, by the way, but I know there's going to be demos, two demos, three demos, a lot of things which we are going to do today. And the the plan for today's session is basically niche is to make sure that people understand how to use dapper with .NET, and of course we're going to touch upon a couple of things with respect to dappers which are very specific to specific to the things which we are going to show in the demo as well. So that's the plan. So let's get started because it's a packed agenda. It's going to be 1 hour plus for sure. We want to make sure that we cover everything in this time slot. So
Yeah.
to
And
begin with, yeah,
isn't it good to get back to microservices? Like it's been a really long time that we haven't chatted microservices. We did an entire I don't know, series. What do you call it now? Now is it series? You call it a series or something like where we did like at least about 7 sessions or 8 sessions
yes,
covering in-depth microservices. And
yes, eight,
good to be back doing the same thing
but with dappers.
with Dapper. Yeah, a lot of
Cool.
things simplified. Yeah.
So Nish, we should
hmm
ask our audience, who I mean, any cool kid nowadays talks about microservices, distributed systems, and they always talk about anybody who's building startup. And I meet all these startup founders. They
hmm
start with like, I am building my applications in distributed systems. It's monolithics are kind of out, and I know there is a debate about it. Should we keep monolithic apps? Should we break it? Should we go for at from scratch itself? Should we go for a distributed system? So what's your thoughts on it?
Oh, well, my opinion on this is, I mean, I'm not a cool kid for first of all, so I'll probably stick to the basics. So here's the thing. I mean, the way I look at it is like microservices is an architectural pattern, monolithic is another architectural pattern, right? So there are certain scenarios where monolithic works really best because they're simple, they're easy to maintain, they're straightforward. Sometimes when you're on-prem, you're bringing it to the cloud for the first time. You're not looking at the scalability aspect, but you will just want to be reliable on the cloud. Then yeah, monolithic is still great for various reasons, right? It depends on the business and application. Microservices or the distributed systems, on the other hand, is useful for really large systems, like complex systems where there are multiple teams involved in it, and every team has to follow a different release cadence, and they all have to work together independently, right? I mean, all those cool stuffs of the microservices architecture. But when you look at those kind of features, then it all makes sense to have go with microservices. But monolithic is still great. I mean, that's what I would say. I mean, that's my opinion, and that's what even we hear from customers, right? Like everyone wants to be at microservices, but microservices architecture, I mean, doing Kubernetes or containers is not microservices, right? That's just you have the ability to do so, to be cloud native in some form. But when it comes to microservices, it's more in terms of, like, how do you architect your applications, like breaking down into business context, and then having a certain design patterns follow, like design domain driven designs and things like that, which takes it even more complex, right? uh, but having said that, now we are talking about distributed systems because we have this unlimited possibilities of scale with having cloud in that picture. And I think now people are asking about, how do I integrate ChatGPT into my enterprise apps, right? And how do I bring in those AI? How do I infuse AI into the system? So as we progress, the world is getting complex, and the systems that you're going to build are going to be even more complex. So yeah, though, having to know these kind of tools, the availability of these tools, and how you can efficiently use them, makes it even more greater, I think. Whoa, what do you think, Vivek?
Yeah, definitely. I mean, I don't know about, I don't want to take sides, but when I was doing DevOps for monolithic, it was tough, because everybody was pushing code to one specific code base, and uh, had couple of databases only in the backend, and it's hard to maintain such a system as well. But yeah, I think distributed systems solve that problem, but it also added more complexity into the world, right? It's not just managing stuff, but you will have to go back and see how you want to port from one tool to another tool, because you have bunch of services which is running, bunch of things you are doing, and implementation of, say for example, if you're using a RabbitMQ and you want to move towards Azure message queue, implementation becomes harder because of number of services you're running. You're broken it into a lot of services, and it's hard to move from these different services to services. So in a nutshell, for DevOps engineers, I think distributed system is easier, because teams were also broken down into different services. So it was like couple of DevOps engineers were put into to solve only couple of distributed systems, so it becomes easier to manage it, because you're managing only couple of services. So that's how it was, right? So that's the narrative I can drive from this. Cool, but just for people who don't have understanding of monolithic versus microservices, quickly, if you can give an idea, Nish, that will be great.
Yeah, so I think this is a very traditional architecture that we see all the time, right? Where there is a typically web app, and then we break down these things into a couple of modules, and essentially these modules may run on the same VMs or multiple VMs. But then the data store, at the end of the day, it's always the relational database that is you maintain it at a either in a different VM, or having, if it's on-prem, then you do all those backups and other kind of stuff that's needed for the infrastructure, right? Even though we break this down into modules, like for example, I think this is an example of an e-shop application, which is like a e-commerce application. So you have the catalog, identity, basket, and all those things. So you break this down, but essentially you break down as part of services, but eventually they all get connected to the relational databases, right? Um, so there it is. Okay, you just moved one step
Yeah,
forward.
I should show the slide, which is microservices.
Yeah,
breaking
so,
that breaking that services into smaller
correct.
services.
Correct. So when you break down in the services, I think the essential part to note here is how the databases are also separate, in services. And that is the key aspect, because one of the reasons the monolithic architectures can't scale to the extent is because it's always bottlenecked to the database. So when there are like multiple services that are scaled, then the kind of things that you need to apply on the database to be making sure it's consistent, it kind of like gives you the performance troubles there. So when you split even the databases, then essentially each service will know about only itself or its data, and the way it communicates with each other is basically through either synchronous communication or asynchronous. In this case, what you're seeing here is if, say, an order microservice wants to tell the basket microservice that anything which is there in the cart has been completed, that means the order has been placed, then the basket microservice need to remove that item from the cart. So the basket microservice is nothing but a shopping cart. So it needs to remove that. And the way to do that is whenever you create an order, you send an event, and then you may use anything. Event bus, it could be a RabbitMQ. The implementation can be anything, like for example, RabbitMQ or Azure Service Bus, or whatever works best for you. And then the subscriber would basically look at that event and then take action on it. So it's like an asynchronous communication. Right now that data are distributed, you need a form of connecting with each other. So that's the best way to do that, is using event-driven architecture, or driven by the asynchronous messaging patterns. Now, the way you get in, like connecting all these services, they are split into multiple. You don't expose, I mean, the best practice is not to expose all the services out, because now you may have, think of those modules. If those modules are what you made it into microservices, then you may have like 20, 25, 30, right? You'll have multiple modules or exposing their endpoints, and that's not the right way to do it. So you probably will have an API gateway where that's a single entry point that you can implement a lot of things, like TLS termination, or any of that thing, firewall security. All those things can be applied at one endpoint, and then you let the web and other consumers connect to it. You can have multiple API gateways. For example, for mobile, you can have a different gateway. For third party, you can have a different gateway, and you get further granularity in those aspects. So basically, I mean, immediately from this, you can understand that the microservice architecture gives you that benefit of being independent and being flexible, and yet they all work together based on the contracts that you define and how you react in response to events, right?
True. And
Um,
and if you see this, right, so if I am a developer uh, in the normal environment, monolithic environment, and if I have to convert all of these things into a microservice environment, there are a bunch of challenges. uh, I already have a monolithic and I want to move towards this, and even if this is a new service which I'm building, which has nothing to do with the previous one which I already have, but new service which I'm building, yet as a developer I need to upskill myself, because couple of things which is not here is the uh, state management, or probably how do you manage the observability, logging, and other things for different services, and also implementation of these pub sub which is there, which is again an important thing, because all of these things requires instrumentation in the code, right? You need to change things in the code. So if I'm doing this, it's pretty easy, and I already know all of these things is handled through only one set of services, right? But if I'm moving to this kind of an environment, and maybe different tools I'm using to solve these problems, it would become a challenging, and it's basically complex. And maybe that is the main reason why dappers came into picture, where the distributed application runtime to solve these complex problems, make it easy for developers either moving from monolithic to microservices, or they're getting started with microservices, but uh, yet they need to understand all of these implementations, and for different tool sets as well, because in one of the 110 set of services I might be using certain set of tools, but maybe the other 10 microservices which I have, maybe I might be using different set of tools. So all these requires different implementation in the code. Maybe that's the reason why Dapper came into picture, right, Anish?
Yeah, so absolutely. I mean, as you rightly said, the biggest challenges that we face with distributed systems is there should be an easier way to kind of like observe them, in terms of like, how all these systems are coming together and how the transactions are passing through it. And also there are, as you said, there are a lot of other things there, cross-cutting concerns that we call it, right, that needs to go into your code to basically work with other systems. So for example, if the basket needs to know about order, you need to explicitly say, okay, which environment you're running in and where is your basket API, how do you reach to that API, right? And you need to write that in different uh, places in your code to make sure that you're connecting it right. And same if your implementation is for event-driven architecture is like, for example, if you are using a RabbitMQ, then you will have to have those RabbitMQ related code in your application. And then if you suddenly decide to move to something like a cloud-based PaaS service, right, something like Azure Storage Bus or something, then you'll also have to bake in those SDKs in it. So there's so much of complexity involved in these things, and it's not only for one service. Now you'll have to go and do it for like multiple services out there, right, which are out there. And some teams go on to do it in a different language, right? You may be using .NET on one microservice, you may be using Go on another something else, right? And they need to talk to each other in the same context defined by the business, and same infrastructure policies that needs to apply. And also, like, when two services are connecting, there is also resiliency that you need to take care. So I think what Dapper is trying to solve here is, because these challenges exist as a developer, and how do you take that kind of challenges out of your business context or out of your business driven code, and then give that additional layer where it will take care of all those things, and your code needs to only be aware of the Dapper, or how do you connect with Dapper. And Dapper is, as its name suggests, it's a distributed application runtime. So the runtime sits with you, with your app side by side, and it will take care of doing all these cross-cutting concerns. And you only worry about your business logic, focus on what is your deliverable for your customers, and then not worry about the other aspects. And it builds on these building blocks. You can go ahead and explain that, Vivek.
Yeah, these are, I mean, if you see, there are challenges, right, in the microservices. The Dapper team, what they did was they broke those challenges into building blocks. Say, well, it could be service to service discovery or state management. When something fails, how do you store all those information which was happening, and you're storing it. And then there is publish and subscribe, again, those implementation, uh, triggering and actors when in terms of your working with concurrencies and other things, and observability, which is logging your metrics and other things, and security and configurations, managing those configurations for different microservices applications. For all of these were, if you have to go and build a proper microservice applications, if you are using different set of tools, you will have to go back and implement in code. You have to go and instrument in the code to enable all of those kind of tools in these different building blocks which is required to scale your application in microservices. So that is where Dapper came into picture, and it's pretty good. And we will see an example today as well, how it actually
Yeah,
solves a
just
certain problem.
a quick thing over there. I mean, I also want to touch upon how easy it is to kind of like stitch in Dapper into your code. Because if you look at the top thing, it's just the application code and supports Python, .NET, Java, Go. But under the hood, you can connect with the Dapper's building blocks using just an HTTP API. So in any language, you can do a HTTP client call to the server, which is localhost, and then Dapper has the specific, the naming convention that it follows in the URL. If you try to keep that same way, then it's pretty much you will go through the Dappers. And Dapper, the way you configure Dapper is basically using your configurations and things like that, and then it will take care of connecting to the other services, as well as other even external dependencies if you have, right? And the beauty of Dapper is, like, it is not dependent on your like cloud. It's not a Microsoft Azure only or something like that. Dapper itself is an open source. It's part of the cloud native CNCF foundation. So you can run on Kubernetes. I think the most common thing that we have seen so far is people running on Kubernetes because of the sidecar approach that it gives the advantage of running on pods. But then you can definitely run it as a sidecar process as well, or and run it on any infrastructure or any cloud of your choice.
And
Yeah,
in Edge, you can run it on
yeah,
Edge as well.
correct. Yeah.
Yep. So that's the next big thing. So
Hmm.
you can run Dapper in Edge, and you can manage a simple service there, and add all of these things which is required, and then you can basically go live within 30-40 minutes of your code written, right? So that's the beauty of having Dappers. These are building blocks, basically. It's called building blocks because the service to service invocation, state management, all of these are specific building blocks. But uh, there are the components are these. Say, for example, if you're using publish and subscribe in a message broker, there is Azure Service Bus. You're using Redis. You're using RabbitMQs. For all this, you are going to use Dapper API, and with that, the building block is nothing but the publish and subscribe building block, and then it connects to all of these components, which is there. The support is there for all of these components, and you can add many components to it. If you see here, there are 70 plus, actually even more now, components are available. So that's one of the example. If you take other examples like secret store, so you can get started with secret store without even putting any code into your implementation, right? You just bring up a Dapper and then connect to the building block, which is secret store, and then you have these services running, and it starts interacting with any of these services which is there. So that's how you can use these components and building blocks, and we're going to see those as well, Nish. Let me move to this. But so this is how it works. So basically, you have your own service, and this a service is running with a process, or you can call it in the Kubernetes world, it's a different container with a different container with the primary container which you have, and it is being talking to each other through uh, protocols, the HTTP and gRPC or gRPC, and it is connecting to Dapper APIs, which is running inside a container. And there is a building block which we discussed, right? There are a bunch of building blocks, and there were components. So if you are using Redis cache and Azure Service Bus, um, the any incoming and outgoing request between your primary service is going through the sidecar, and the data has been captured and being pushed to both Redis cache and Azure Service Bus. And for scaling purpose, you might be using some Azure Service Bus, and maybe you are doing some other activities with that. Probably you might be using logic apps, and probably you might be using Azure functions to do some kind of activities, right? You might not be using Redis cache for that. Maybe you want to store something else, specifically, maybe for logins and other things, and you might be using Redis cache. So all of these things is run through sidecar. That means if there is a request which is coming to your primary service, it goes via the sidecar which is running, which is a process, which is a container which is running with your service. And that's where all the details will be captured and stored, and then your primary service also respond to this request which has been sent to it. That's how incoming and outgoing request goes through. Nish, you have any more thing to add here?
No, I think you covered all the points here.
Perfect. So this is a simple example. There you have a code, and you run it with the Dapper API, and these are the building blocks which it supports. and you talk to these building blocks, which are into, it is talking to the components. And in the Kubernetes world, you we run it as a pod, and you have two containers running. One is your primary container, and the other one is the sidecar container, which with the API, with the building blocks. And you have your services running, which might be like Zipkin service, or might be your Redis service or RabbitMQ service, which is running. And through this kind of architecture, through this kind of communication, you can talk to those services, and push the data to those services, get data from those services to your application code. So we'll just go and show a couple of demos, Nish, so
Yeah,
that people can get
absolutely.
this in a better way. uh,
Yeah. So meanwhile, everybody on the stream, feel free to ask questions. We do generally a casual chat, and we see some really good people joining in from different countries: Colombia, Brazil. Hello, everyone. So feel free to drop in your questions, and we can take that up. And yeah, we do this as a casual chat show, which is called Samosa Chai, where we talk about random things, as well as we go with the primary topic, but we also go in the random spaces too. But today, since Vivek mentioned he has a lot to cover, we're just trying to doing our best to stick to the schedule, so that we we go through that. So yeah, please feel free to drop in all your questions there. We'll take it up.
Cool. So, from a demo perspective, Nish, we are going to work with the observability building block, and specifically, build an observability for people who have joined you. And what is an observability? You don't have any background towards it. Is It's primarily four pillars. One is distributed tracing. Tracing is basically, you want to see the insights of traffic between services, and some transactions happening, and you want to see the performance and other things. So that's where tracing comes into picture. And from a metrics perspective, you want to see performance of the resources, resource consumption, like CPU consumption or the memory consumption. That's where you want to see metrics, right? And logging is basically, your application is executing a code, and there is some exceptions which is coming in, and you're capturing those exceptions. And if there is null point exceptions, famous, right? Nish mentioned that you're writing Java as well. So that's, that's the kind of exceptions you get and the logging, and you're going to capture those kind of information as well. And health is new, right? When two different services are there, what is the health of this service? And this is primarily seen in Kubernetes, right? So, observability perspective, there are four different things, and you want to capture all of these things in a different tools, right? So if I go back to the one of the slide which we are talking about, the observability, um, there could be Prometheus. You might be using Prometheus, you might be using App Insight, Zipkins for tracing, Agers for tracing, Prometheus for metrics. And if you go back and use Open Telemetry, you're going to use log and log management as well.
Yeah.
There are different components which is getting added in there, right? So all of these things, if I have to implement, uh, I need to go back and instrument the code, right? And for each and every services, say for example, if I have 35 service microservice or 40 microservice, if I have to go back and implement it, it's very difficult, because I have to sit and code. The moment you code as a developer, right? The moment you write code, there is a bug, and you're going to break the production, right? So that always happens, right, Nish? So
Yeah.
um, so
Just to
so how do we
touch on
solve
that.
this problem?
Yeah, just to
Yes.
touch upon just thing. I mean, Dapper technically provides you only the building blocks. So implementation and the details are the tools that you use. For example, since we're talking about observability, you can use something like a Zipkin, um, or Jaeger, or application insights. That's choice is up to you, but your application will only know, what do you say, about Dapper, right? So that's the cleanness that it brings in.
True. That's true. And by the way, when it basically pushing all these data, so you have so many things happening, right? If I am doing it for the first time as well, I need to go back and instrument it. If I am doing it for already I have Zipkin, for example, I already have that implementation of Zipkin. I want to move from Zipkin to Eggers. Uh, that's where the portability comes into picture. So distributed, the meaning of the name is like that, right? Distributed application runtime. It's used for portability as well. So you already have something which has already been implemented, and you want to move it to different tools. uh, that's where you can use tappers as well. So let's see the example of from an observability perspective. Say let's go back and see. So uh, the example is pretty simple. We have two services, and we're going to run, obviously add dapper implementation to those two services, and collect the information. And basically, for an example perspective, you're going to see Zipkin running, and we can see the data coming into Zipkin without making any changes to the code. So I would have not done touched any piece of code. I will have the same code which is running. All I'm going to do is add Dapper on top of the service which I have, and then I have Zipkin running for me. So let's get started, Nish.
Um,
Then,
there's some
or you
questions,
have
so
any
let's
questions?
answer this.
Yeah.
So we have a question: Dapper act as kind of interface between microservices and cross-cutting tools. Yes, it's an application runtime which takes care of all the cross-cutting concerns, and they are implemented using the building blocks. We have another question. What is Zipkin? Okay, Zipkin and Yager. So we'll show that right now, and then you'll get a better idea about what it is. So
Yeah.
it's a distributed tracing tool in short. But yeah, go ahead, Vivek.
Yeah. So let's get started. So I have a simple code, which is ASP.NET code. Nash.
Great.
So I have a code, and which is in ASP.NET. And
For those of you
I
who
mean, I
don't
don't
know
want
the
to.
background,
Yeah,
uh,
I'm not a
Vivek
.NET developer.
Vivek is not a .NET person, but he is. From the last 1 year, we've been training Vivek on .NET, and now he's just as well versed as he's in any other language that he was already familiar with. So, and it gives me immense happiness in seeing Vivek smile and be successful in his endeavor to learn .NET. Uh,
True. And it's a simple app, basically, and we're going to see what that app is. Um, so I will not go in depth with what this code will do and other things. It's a simple application, and the most important thing is I have a Docker file. There are two parts to this, right? You can use Dapper with SDKs, and you can use Dapper with just the Kubernetes, right? So, and in your Kubernetes manifest files, right? So so to start with, I have two services. There is backend service, there is front end service, and both of them are Dockerized. And I have made sure that this Docker images are sitting on Azure Container Registry. So I already have them on Container Registry. So if I have to show you uh, Dockers and show you my Container Registry here, so I already have. So back end and front end both. Okay, so I have these two different images already there, right? And all I'm going to do now is going to push this into the Kubernetes cluster. And let's get started with that part, because there's a bunch of things which we are going to do from a Kubernetes cluster perspective. um, Let me get, most important thing is to install Dapper onto your CLI. And once you install Dapper, you will be able to see a couple of command line help. So you can see there is bunch of things which is there. So we'll first thing what we will do is push a plain application. There is no Dapper implementation, nothing. So we're going to push the plain application to the Kubernetes cluster which we have. So let's go ahead and start first. Okay, so let me start with the name. What is the name? What is the name I gave? I have, I missed the name. Here's the name.
Chaiwala.
Chaiwala.
Nice.
Because it's samosa.chai.net and that has to be Chaiwala, right?
Okay. So what you're doing right now here?
So basically, I'm adding credentials to access my Kubernetes cluster. Cluster is on
So you already
Azure
deployed
Kubernetes.
this.
I have already deployed the cluster, so it is already there. So we don't have to be. It's already running because I don't want to waste time in creating a new cluster. Right? It's already running,
Mhm.
and I just added this into the service. Let me show you my YAML file, which is there. Let me go back to the code, and I have back end and front end YAMLs. This is a simple YAML, right? This is a service. Front end is obviously on the load balancer type, and I am running a container which is already there on my Azure container registry, and this is a simple deployment. And there is backend service which is again similar to the what we have deployed, but this is not a again load balancer because it is a backend service and it is already there. But notice that I don't have any dapper implementation yet, so it is just a plain code which we are doing, and it's very simple thing which you usually deploy, right, without anything. So let us go back and deploy this one first. Let's do backend first, and we're going to do front end. Okay, so I'll just deploy the code there.
Yeah. While you do that, I'll just take one question.
Yeah,
Can we use Dapper outside Docker or container world? Let's say I just have a bunch of microservices, just want to take benefits of Dapper, gluing the things. The answer is yes. So Dapper, I think I don't know. Did you show this slide before, Vivek, between the sidecar and the sidecar in a container?
yep, yep,
Okay, so you keep continuing. I'll talk about this. So Dapper is, you can run it as a separate runtime alongside your application, so you don't, it doesn't have to be containers. So that's the simple answer to it. The advantage of using inside a containers is basically those, sidecar techniques that you can utilize with the pods and things like that is the advantage you get. But there's no reason to use Docker. You can obviously, if you're not using, you will have to use the Dapper CLI and use the Dapper installations and things like that to go side by side with it. So
yep.
cool.
So that's it. So this is the samosa chai store, Nish.
Mhm. Nice.
Okay,
So
so
basically, let's recap. I think what you did is you already created a Kubernetes cluster and just kept it. And you also had a backend and a front end. I assume the backend is where the API is, which gives you all the samosa chais and ingredients and things like that.
correct.
And then your front end is the UI that you're actually showing here. So what you
Yes.
did is you created the YAML files for deploying backend and a front end, and then you applied them. So now it went and pulled it from your container registry and installed it into or deployed it into the Kubernetes. So now we have a working app of a
App.
front end and a back end, right?
True. That's
Yeah.
it. So basically, it's a simple app now, and now
Mm,
what we will do is the most important thing about Dapper is you can run it without without Kubernetes, right? So you can just go and say Dapper init and get started on your local machine. But if you want to work with Kubernetes, you should make sure you have a config set, uh, get context. So basically, it has to be set. Okay. So
Mm.
this is set. Actually, if you're not setting this, and if you run any of those dapper commands, it might go into different clusters. So if I had different cluster set, and I am planning to run it on this cluster, um, then you might miss everything. Okay, so make sure that if you're using Kubernetes and with Dapper, and you're running through CLI a lot of commands and other things, just make sure your context is set. And my context is actually set to Chaiwala, so I'm going to use that cluster. So that is my cluster, and it's a very simple command, DAPR init hyphen k. There is bunch of things it installs, and we'll see what all those things. But uh, this is what it is doing. It's basically deploying Dapper onto the control plane of your cluster, and it would install the operators, the dashboard, the the server and other things. So we will see within a minute or two. It will install the Dapper onto the Kubernetes cluster which I have. Okay, so if there is any questions, you can ask in the chat, or else what we can do is we can sell this to basically in Shark Tank, like how much percentage and other things. Nish. While
For
this
the
is happening.
samosa chai app, show me what exactly you're showing there. So that's
Chai
oh, so
store.
you're saying each type of samosa and then their ingredients and the cost in what they're saying. You're okay. You're saying if it's in stock or not. Nice.
Yep.
Okay.
So which samosa do you like here?
Um. Yeah, probably an onion samosa. I mean, I've not had it in a long time.
Onion and ginger tea. Yeah. Yeah.
Yeah.
Ginger chai.
Nice.
It's still
Um.
taking some time.
Okay. So what it is doing is basically installing or deploying Dapper onto your Kubernetes cluster, which is your Azure Kubernetes service, right? AKS.
Yeah.
Okay.
I don't know why it is taking so much time. It should be fast.
Oh well, it's a demo time, so obviously,
Yeah.
I will not be
Whenever
surprised if
it's
we see an error here. I'm not going to jinx it. Sorry.
Please don't jinx it. It's already so much in Dappers, right? You have to remember so many commands. You have to work on so
Oh,
many stuff, right?
we have samosa fans. Amit says he likes samosa pav. That's nice.
Yeah, I mean, audience can tell us like which samosas they want to buy from our stock. I mean, I can share my you know my UPI ID. Uh, you can all transfer that money to me and probably expect samosa reaching you.
I don't see any shopping cart here. Like, how do I add samosas?
Yeah,
How do I place an
I mean
order?
that I will get after getting money from Shark Tank.
Interesting. Um,
Ah, yeah, it's done. Okay,
Great.
so we'll get back to the
Can you
dappers.
do a
Okay, so
kubectl
yeah,
pods for me once? I just wanted to see.
it will show in the status
Okay.
command, dapper status k command. It will show me all the
Okay, these are the things that.
running
Okay.
services. Yeah, so these are things which it basically installed: operator, dashboard, sidecar injector, and Sentry to manage that, retry, and all those stuff. So
Mhm.
basically, basically it did add dappers to Kubernetes, not to your application yet. It is just to your Kubernetes cluster. We have added dappers, control onto the control plane as an operator, but we need to go back and basically do the rest of the things while these things are all set. Okay, what we can do is basically get the Zipkin installation done. So let's do the Zipkin installation, and then we'll go back and make changes to the code, which is the YAML files, and then deploy it back onto the cluster. Okay, so um, let's get started with the Zipkin installation first. Before I do that, I want to make sure I have the config, you know, get context. Okay, this is there. So let me do the Zipkin installation first because we're going to show Zipkins. So I have Zipkin image installed. That will be very fast. So, and we will expose the port. Okay, I'll keep this open. Done. So let me go back here. Now let us try DAPR configurations on Kubernetes, right? So as of now, there is no DAPR configurations on Kubernetes because we haven't done any configurations. So if you see here, there is it's empty, and we haven't set any configurations on top of any of these building blocks, right? So what we were going to do now is we're going to go back and see one of the thing which is called DAPR configurations, and this is the YAML for that. And if you see here, it's a simple configuration for Zipkin. There is multiple YAML files and structure to this for different set of tools. So the only thing you're going to do here is you're telling we're going to use Zipkins with the dapper, and you can see here it's a configuration file with the dapper operator, and your tracing is sampling rate is one, and endpoint is this. So all you're doing is configuration. So what you're going to do now is basically go back and apply this configuration, right? So dapper sorry, kubectl apply -f configuration. So now you've applied the dapper configuration, right? And but this is still at the other side. It's not you have not added anything to your application side. So basically your application is running, and you have the dapper api is running, uh, and dapper server is running basically, and where the configurations is set to access the zipkins, but it is not yet set the application side. If you see this command again, right? So if you see this command, you will see dapper config tracing is true, metrics is true. Metrics is always enabled true. Otherwise, you can disable it. This is in default namespace. You can add it in the namespace, wherever you're running your application as well, right? So this is done. Now you're going to see the application side of it. So we're going to go back to my backend YAML file, and you can see here, I have commented out a couple of code which is specifically for adding dapper to your YAML. So I have not changed any code. Okay, so if you see here, I haven't gone to my code base and changed anything. All I'm doing is changes in the YAML file uh, to get started with zipkins. So it's very simple. So all I've done is just uncommented this. So this is the configuration. This is the name of the my configuration which I had given. So that is the same name, and rest is all the name and ID and the true to enable the dapper IO, right? So that is all I'm doing here. So you don't need to give everything. It's basically you need to go back and check what are the things you need from the API to make use of these specific things from a dapper perspective. So I've enabled this on the deployment and our backend and front end code, and we'll go back. I've saved this, right? So I'll go back here, and we will go back and execute what? We'll deploy it back because we made changes to the YAML file. So we will go back and deploy this, right? So we have deployed it, And now we will go back and check Zipkins. Make sure Zipkin is available on my local system. It's running. Cool. So I'll go here, local host. So my Zipkin is running. If you see, there is no query coming in yet, um, because we will go back and see get pods. So you can see here, this has two different. If you have seen observed it previously, it would have one. It is now two because let me show you the services it is running. You'll see a sidecar running now. You can see here there are two sidecars, which is backend DAPR and front-end DAPR. Basically, it is part of the Samosa backend and Samosa frontend. Okay, so now if you want to observe this in a better way, you can see it in DAPR dashboard. Okay, which is for the Kubernetes cluster which I am using. So you can see there is bunch of services which has got added into my DAPR dashboard, which is Samosa backend and configurations. Right, there is log, everything is coming in, and here again for the same stuff. Now this is, I'll just refresh this page. I'll just copy this again and probably come back here and run this one and go to some place, go to some, click on some stuff. And if you see here, there is nothing. Again, you see here, Samosa backend and is running, right? So this is where tracing comes into pictures. There was a question on what is Zipkins, what is Agers. Uh, if you're tracing these requests, right, there is a request A, and in between there are a bunch of services which is been running. So if I have to go back to my observability slide, so if a request comes in, it's called a trace, and within that there is bunch of services it is going to interact. Service A to B to C to something else. So to to respond to that particular service or that particular request, it has to talk to bunch of services in between, microservices in between, and then share the result back to the user. So it is called spans. That's what it is. And basically this is used to see the performance and other things, which is specifically for A to B. Is the performance bottleneck, or C is down and B is not able to respond to A? Why C is down? We don't know. So basically there might be a couple of requests it is not responding to. So those are the things which you can find. And if you see this one as well, it is taking some time, and suddenly this one took a lot of time, so it would show it in red. So this is already giving me information that one of these requests is slow, and which is having a performance bottleneck. The other request is fine, but I need to go back and figure out adding much things into the implementation to get more data, right? So that's what a Zipkin does. So this is very simple, Nish. So what we did here was, we had a cluster, we had a simple app which was running, which is a Samosa chai store, and then we added Dapper into the cluster, and then we got the configuration done for the Zipkin to be used, and then we added the implementation, which is the annotation uh, into our code in YAML file, which is Kubernetes manifest, and then we just ran that, and that's it. I didn't do anything, but Zipkin is running already for me, already showing me there is an issue. right? So that's what Dapper does. So over
Yeah,
to you, Nish.
it's yes, it's pretty easy the way the sidecars work. You know, like you don't have you. I mean, if you don't notice, like you didn't make any changes to the code, and it automatically Dapper took care of the taking care of the trace. It injected the trace ID, and it can go through those things. Okay, all right, let's switch gears. I think we have really less time. But yeah, for those of you who are joining us, this in the same URL you will find the video for a later watch. So if you are in a hurry to go out of the stream, feel free to come back later. So we'll cover a little more. We'll extend time a little more to go in talking about end to end. Like how do you see the application end to end? How do you do in production, right? So what are the things that you can use? I'll briefly touch upon a few things. Okay, let's take a look at it. So I'll start with let me bring in. Oops, I think we are clicking at the same time. Vivek, this I'm gonna do it. Okay, there you go. So so this is my screen, and so if you are someone who is new to microservices world, I will encourage you to just use this URL called .net slash go to architecture, and it has this like complete end-to-end guidance on how do you build production-ready apps. And this is something which I've been PMing on. Like I work with a lot of authors to get these kind of content out, and we also basically work on the latest and greatest on the .NET side as well, on the cloud native stuffs. So this is one of the most popular books out there, which is a microservices architecture ebook. So if you're someone who wants to understand how do you get started, start with Docker, how do you build, what is microservices, how do you do domain driven design, it briefly touches upon a lot of things, but very important aspects of it, so you get the overall end-to-end picture. And I think we wrote this book about now close to about 4 or 5 years, and it's been really popular and everybody likes it. So when Dapper came out, I worked with the Dapper team to build this book as well, which is called Dapper for .NET Developers, which focuses mainly on whatever we have built here, right, in the microservices architecture book. So that uses something called as eShop on containers, which is, let me show you that quickly. This is a kind of a microservices. It's a largely it's a reference implementation, but it's more like how do you build microservices in the real world, right? So you can see that there is identity, catalog, ordering microservices. They're all having different databases, SQL Server. The basket microservice uses a Redis cache. It uses a backend for front ends and implements API gateways. It has event bus on the right. It has RabbitMQ and all those things, right? So this has been this application has been there for a very long time. And so when we decided to write the book for Dapper, we needed to have a companion reference architecture as well. So then we built something called as eShop on Dapper. Before I come to that, I'll encourage you to go to this site, and you have a free ebook. So we don't ask first name, last name, and email, and all those kind of things. If you just click on download PDF, it just comes to your device automatically, and it has like an end-to-end implementation there. So if you go to eShop on Dapper, you can see that the way we took eShop on Dapper approach is basically how do you Dapperize this, right, end-to-end architecture. By default, eShop on containers have these containers, Helm charts for deployment. It's on Kubernetes. You can deploy it on Docker Compose locally. So we took that and said Dapperize it and see what benefit we get, right? So we got a ton of code removed from eShop on containers because now Dapper was able to do that for us, right? So we had code like if I'm running on RabbitMQ, this is the configuration. If I'm running on service bus, this is my configuration. And the way you configure things, the way you connect with them, the ports, the other settings that you configure, they're all very different, and that's why the complexity increases, right? And it was super hard to maintain that. So if you look at eShop and Dapper, it kind of like takes away all of that thing, and then just the code is much cleaner, much easier to maintain, and makes our lives easy. And so look at this. This is the eShop and Dapper. So you have the Blazor front end. Blazor is nothing but a UI framework for building applications, web applications, using C# instead of JavaScript. So we use the Blazor frontend, and it connects to an API gateway, which is implemented by Envoy. But then there's a aggregator. Technically, think of scenarios in a mobile screen where there's one screen where you have a customer info and you have a order info that you need to show, but essentially they're coming from two different services. So instead of making two calls, what we do is we call to an API gateway internally to the aggregator, which will aggregate, connect to all these services and pull in the data. The advantage of these using aggregators like this is like you can also cache there for faster responses. You can work with multiple services, and you can basically it's a backend for front end implementation, right? And you can see that there is also this event bus there for any communication that you need to happen between the three. Okay, that much for the architecture. Let's go look at the code. Not the code. Let's go look at the application. So unlike Vivek's application, which only shows Sambusa Chai, we'll see a working application where you can actually make some orders.
Hey
So
Nish,
yeah.
in previous series, I ordered so many stuff. I didn't get it, man.
Mhm.
Nish.
Yeah, it's you didn't pay either, right?
Yeah.
So
Sorry. Go ahead. Go ahead.
So if you go click on the login, very advanced dashboard here. So you can copy and paste the username here, right here. So again, this is for test, right? So this is running on my local right now, using the Compose up. So here you go. So you can see that this is the login. So this is, I can choose things that I want to buy. I definitely want a Dapper cap. I want a Dapper sticker. I want a Dapper hoodie. And then once I do that, like you can see that this is the basket service where all the items are actually loaded here. I can go and increase. I need more stickers. And then I can go ahead and click checkout, and it asks me for the shipping address and details, and let's say place order. And now as I place order, you can see that what happens behind the scenes is it just goes in, order service makes a place, so makes an entry into the database, and then it raises events for other services to come in and pick. And you can see that slowly the status will keep changing. And the way it is working is using Signalar, because behind the scenes there is services that are running and moving it based on certain criterias. It's looking at the event bus, taking the data in, processing it, validating it, and then sending the notification to the client saying, okay, these status are updated or whatever, right? So you can see that it has gone into the page status. So this is the general simple thing that has been done. Multiple services come together to form into this, right? So I'll show you the code, which is over here. So this is the eShop on Dapper. If you go to from the book, it has. So if you go to the book, let's say, okay, if you go to the book Dapper for .NET developers. So what I did is I clicked on View on the web, because instead of downloading the web PDF, if you go into the reference application, so here you will have details about eShop on Dapper. So you can click on this to go to the eShop on Dapper implementation. So right here, it's the eShop on Dapper thing, which I showed you right now. And you can run this completely on a CLI, on Visual Studio, VS Code, or even on Azure Container Apps, so which is something which I'll show to you later. I've also deployed it on Azure Container Apps. But right now it's running on my local. You can see that I did a Docker Compose up, clone the repo, have Docker Desktop installed, and then did Docker Compose up. So I have all the services running. So if I go to Visual Studio, you can see the kind of images that I'm running right now. If you go to Docker, you can see that these are the images that's running here. Right, so there is RabbitMQ, there's Redis, there's also Zipkin, and there are a lot of clients and things like that that's running. Right now, the first thing Dapper solves is service-to-service discovery, right? And that's where we were talking about. Okay, now when an aggregator connects to multiple services, how does this even work, right? So let's go to the VS Code and see how service-to-service communication works. So to give you an example, let's go to the aggregator. So by the way, this is the code, and this has src folder. Within that, you will have multiple services here. Again, this is done to make the life easier for developers to get started quickly. But in reality, you will have services in different repositories, and it's very hard to kind of like pull up a service on, directly working on local. But this is a reference architecture, so we want you to get started quickly. So we have everything inside of this one folder. If you go to the API gateway aggregator, I was talking about the aggregator. What it does is it'll aggregate from multiple services, which means it needs to know the service discovery, right? So how does it do, right? So if the aggregator has to call a basket service, and you can see that this is just a basket service, and there's HTTP client, and it is making a call called update async, which basically makes a call to the basket API. So this is the endpoint. So this is the method that I'm going to call, and this is my the API endpoint, like the version 1 of the API that I'm calling. That's all it has, by the way. So how does this really work then? How does the dapper know how to connect to that service, right? And for that, what happens generally is when the program extensions, this is what we do. This is a dependency injection. And because in .NET we have a Dapper SDK, I don't have to write HTTP localhost 3500 or whatever Dapper related ones. Instead, I can say Dapper client.create invoke HTTP client, and I can say which API I'm trying to call, right? It's called the basket-API. So as long as you have a configuration written for the basket API, Dapper will know to connect to that API directly, right? And to quickly, since Vivek was showing you Zipkin, so we have the Zipkin also is baked into this. So if you click on the run query, and you can see that right now, whatever order that I placed about 4 minutes ago, if you look at the web shopping aggregator, I go to the show. Okay, this is not the one. Let's go to the one which is from the basket. Let's go to the catalog API. Let's see this one.
So Nish,
Okay.
can you just zoom in?
Still zooming?
Yeah. Yeah.
Okay.
Works.
It's like, but heavy, right? Go
Yeah,
120.
that's
Is
fine.
okay?
That's fine. Yeah.
Okay. So if I go into the ordering API, for example, this one, right? What happened? It didn't like the zoom. Okay. Let's do it again. Show something with the zoom in. I don't know. Let's see. Run query. Let's take a simple one. But then show. Okay. Should I?
Go back to Zoom.
Yeah, it's some sort of. Okay, let's open a new tab. Let's see if I can get it.
Yes.
Yeah, it doesn't for some reason. Let's create a new window and see, new private window. That's all. Okay, I don't know why. Anyway, so ideally, what you would generally see is the
You
entire
can just
end-to-end.
expand. You can just expand that Zipkin trace, and you can actually see. Just expand that. The one which is
Like this.
yeah, that one. Yeah. Anyways, you can see those different services which is touching right in bottom,
Yeah,
and couple
yeah,
of issues which is having.
yeah. So yeah. Anyway, I think it's just a temporary thing. So you can
Yeah.
actually trace that entire ID, but it was really interesting to watch that. You can completely see each event that is processed, and because there are multiple services involved, it gives you that entire thing. And I can also go to the dependencies and show you this, like how these things are working. So from the aggregator, it makes a call to the order API and how it comes back to the basket. And you can see that these are email sending and all those things, right? So yeah, so basically, all these things come into your application the moment you integrate Dapper and configure it correctly. Okay, let me go back to my VS Code here. So that was a really simple one. And to show you a little bit on Dapper component, okay, let me try and see if I have this configuration somewhere. Okay, no, I don't have that here. So basically, this is the I'm just showing you the I could show you Docker Composer, but since I'm going to deploy this in Container Apps and show you later, you can see that the name that I define here, that's what matters for Dapper to identify as a basket API, and that's how we are trying to make calls directly. So that's the service-to-service invocation that we're talking about. Okay, so that's about the service-to-service invocation. We can go further into say how we are implementing cache, right? For example, let's go into the eShop on Dapper, and if I make a thing, like add a thing to the cart, item to the cart, and you can see that there is a basket, right? So if I go to the basket service, there are 2 items here. Now, if I go into my Redis, if I refresh it, you can see that this is my item there. So I have the basket API, and I have the items that I added in that Redis cache, right? Okay, now let me show you on Azure right now. The same app is deployed on Azure, but if I go here and search for my Redis implementation, either Azure Redis PaaS service or a Redis container, it's not there, right? It's so I'm like, okay, what happened? Why is it not there? So if you go into the VS Code and go to the deploy options and go to the container, so let's go to the DAPR components first, and I'll show you the secrets, the state store, right? So the way we implement that is we use again the DAPR's this one building block for managing state, and we use the Redis for that configuration, right? So that means when you're running locally, it is running on Redis. But the moment when you decide to deploy to container apps and under the hood Kubernetes, if you go to the state store, if you look at this same eShop on Dapper state store, you'll see that it is implementing the Cosmos, right? So that is how we are able to flip it using the configuration. But your source, your code doesn't even aware of where it is going to deploy it, right? For example, if I were to go to basket service, and the way we use this is in the let me try to collect the repository. If you go to the basket repository, this is how we make the save for the shopping cart. You can see that we're using the state store, and we say eShop on Dapper state store, and that's all. The code is only aware of it's going to use a Dapper client and store the state. But as the deployment goes in, it can be flipped to whatever state store that you want. And this is the biggest advantage of having Dapper, right? You can just change things under the hood and maintain the code much more cleaner, right? Since we are out of time, I'll show you one more thing real quick, which is the PubSub. And to use PubSub, what generally happens is, let's say if I go to the controllers, integration event controller. So in eShop, we use something called as integration events for a lot of things. For whenever you want to have a PubSub and things like that, because they are events that needs to work with external services, right? So we use integration event. Now, what we did is we went ahead and said, like, okay, this is again a feature that comes with the ASP.NET Core libraries and baked into the Dapper SDKs. You can actually attribute your code method using Dapper and say you're actually listening to this particular event, and then this is the name of the event that you're actually listening to. So in this case, it says order status changed to submitting integration event. That means this is a event. It's a subscriber which is listening to the orders placing. Like, once the order is placed, the order service will raise an event saying order status changed to submitted, and then we need to go and handle that event, basically removing it from the basket, right? So if I go and go to the VS Code, go to the eShop and Dapper, and if I do a checkout, place order, it should go away from my basket. So the basket should go empty, right? And this is handled by these events. And it's asynchronous in nature, right? So the way to do that is, again, as you said, as I said, in the Dapper, you basically attribute it with topic, and it will subscribe to that. And the way you make a call to these events is basically using the event bus. Let me see if I can see that. Okay, it's built on the building blocks. If we can see event bus, extraction Dapper event bus. So here you can see the Dapper client, and then this is what is being called publish async, and you just put in that event that you want to publish. That's it, and Dapper will take care of relaying it either through and in case of locally, I'm using RabbitMQ for my publishing, but in Azure, when I'm deploying it, it is using the Azure Service Bus. And I can show you that by going to the deploy, container apps, modules, Dapper, and if you go to the PubSub implementation of it, you can see that this is the name is same what we give, but then the way we implement that is using Service Bus. But in local, you go and implement in RabbitMQ, right? So you're flipping the switch. How are you? It makes it comfortable for your dev versus deploy scenarios, right? So this is super cool. So I think that's all we have time for. But one quick thing is, this is running on Azure Container Apps. So whatever Vivek showed you so far with Kubernetes configuration and all those things, you don't have to do any of that thing. All that you need to do is basically, so this is basically, Container Apps is basically serverless containers, right? So it's running on Kubernetes. You can take advantage of Kubernetes, and there are, of course, there are a lot of other benefits too. The biggest benefit of Container Apps, for in this scenario for the microservices thing, is it comes with a DAPR enabled. So you can actually, let's say if I go to Basket API and go to the DAPR section here, you'll see that DAPR is enabled by default. So I'm not patching in any sidecars. It is all configured automatically for you because it is built in, right? All that we need to do is, if you go to the VS Code, go to the Container Apps in the modules of, let's say, apps, and go to Basket API, you go and say that you want DAPR to be enabled true, and then provide the app API ID for it. And that's all. It takes care of everything behind the scenes. You don't have to run YAML scripts to configure anything. They all just come to you by default. And there are other great advantages of these things. Like DAPR is MTLS, basically between two services. The way it connect is on a mutual TLS, right? And then there are a bunch of other things. So with that, I think we're running out of time. If there's anything else you want us to answer, happy to take that up. But go and try this out.
There's
Download this
there
ebook.
is yeah there is one question, by the way, Nish. Is this
Mm.
app is on Blazor app?
Yes,
This
it
one,
is.
whichever is there.
Yes, whatever you're seeing here, this is a Blazor app. Yes.
Cool. So that was one of the question, and yeah, I mean, the advantage is so much. I mean, this is so good. One of the thing is, Dapper comes with Azure Community Service comes with Dapper extension as well. So you can install the extension instead of doing that step which I did, which is like installing on the operator on the Kubernetes cluster. We could basically use the extension on cluster directly, and no need to do that step at all. I just wanted to show the installation, but you
Yeah.
can do it without that step. And this is so cool. I mean, the example which is there, it has all the things which is which is required from a dapper perspective, from state management example with the observability examples, with
Yeah.
the service discovery, everything. So I think the book is kind of a
Book
bible
covers.
for
Yeah.
dappers.
Yeah. Book covers end to end, kind of like like I mean that's what we did. Like, we took eShop and containers. We have this heavy, massive application, and we wanted to simplify it, and Dapper made our jobs much, much easier. Because um, I think I can show one quick thing if we have time. Is Let me just show you this. I mean, to the extent that if I have to show you what is the amount of code that has gone scratched out. If you look at this is the eShop on containers code, which we simply have this Azure Service Bus enabled true or false statement. And look at the number of code that we need to write just to get this thing working between. And imagine if I have to have multiple event buses with different services, then the code that you write to have this, and this is not just one here, like there are multiple places that we need to, flip and switch. So none of this, all this code has gone thrown away when we did eShop and Dapper, because Dapper takes care of all those things.
Imagine
I'll stop.
imagine the production issues you would have gotten if you have written that code.
Oh yeah.
That's nice.
That is true.
Cool. I think
So
I think we are just way out of time, right?
Yep.
So if you have any questions, just reach out to us, and we will be back with one more series as well. So um, which is going to start in next month. And if you have any questions, reach out to us. Thanks, Nish, for coming in and sharing all the insights. Thanks, Parth, for hosting us. And see you all. Have fun. It's Friday evening party. I'm going to
Oh,
get
it's
some
Friday. I
samosas
totally
now.
forgot about that.
I'm going to get samosas today for sure. I want to post it uh, on my Instagram or LinkedIn? No, not on LinkedIn. Instagram.
Yeah, that's better. Awesome.
Okay. So
Awesome.
bye.
Thanks.
Bye. Take
Take
care,
care.
guys. See you.
Bye.